Hey, what's going on, everybody? Hope you're ready to learn a little bit about solving linear equations, which is the topic for this video. Now, just a reminder that I'm expecting in these videos that I'm making that you're on an Algebra 2 level, meaning you've already had Algebra 1 in geometry and you've solved a lot of linear equations before. So if this is your first time trying to solve linear equations, you might want to try to go find another video that's on a more basic level. I'm assuming that you can handle equations with variables on one side or both sides already. And really the goal here is to teach you how to do that stuff, but it's just to teach you how to be a little more proficient at it. All right? You're going to, in this video and the next one that I'm going to make involving fractions and decimals, just going to kind of perfect your strategy and make sure you have a foolproof plan for how to approach these kinds of problems. All right, let's get to it. I have basically a two-step process for solving linear equations. All right, now linear equations just mean you have an equations where the expressions on either side, if they were graphed, would produce a line. All right, I'll show you what that looks like if that doesn't make sense to you momentarily, but this is the process I would use for solving linear equations, and I would use something different for any other type of equation. But when you're solving linear equations, here's the first thing I want you to accomplish. Two goals. First, you need to simplify both sides of the equation. An equation, remember, is just simply a pair of expressions that are equal to one another, and we talked about in the previous video how you simplify expressions. So simplify the expression on the left side of the equation, then simplify the expression on the right side of the equation, and you'll have accomplished the S from my SI process for solving linear equations. And then simply, once you have simplified both sides of the equation, the second goal for you is to isolate the variables. All right, which means you want to get, if we're talking about x, for instance, you want to get one x by itself, isolate the variable, and it will employ a series of properties in order to make that happen. Well, let's see all this in context. All right, I'm going to give you a couple of equations where you're going to have the variable on just one side of the equal sign, and then we're going to go through a couple of examples where you got variables on both sides of the equal sign, and in either case, what I'm wanting you to do is first simplify both sides of the equation and then isolate the variable afterwards. Now, I tried in my previous video to emphasize how I want you to show work, and I will do that again here. You might recall that I said when you're showing work, I don't ever want you to have more than two expressions on a single line of your paper for that problem. And since an equation is already made up of two expressions that are equal to one another, that means I'm not going to put anything else on this line. I do want you to copy the problem down. You always copy the problem down. You don't start with your work. And then we'll work downwards to show our work to complete this process. Okay, so let's go ahead and do that then. Let's look at the left-hand side of the equation, work on simplifying it. Turns out the right side is already simplified. You can't do anything else with the 26 for now. But let's work on the left side. And we want to go through our process of following order of operations. You look in the grouping symbols first. Nothing you can do with 3 minus x. And we can't subtract 7 from 12 yet because we have multiplication, right? Multiplication always comes before subtraction. So what we're going to do is we're going to leave that 12 alone, and we'll leave the minus 7, well, let's not leave the minus 7 alone necessarily. What we're going to go ahead and do is use the distributive property here to multiply negative 7 times that difference of 3 and x. So we'll have negative 7 times 3. That'll give us negative 21, so we'll put minus 21. And then negative 7 times negative x is going to give us positive 7x. All right. And then the right side of the equation already simplified, as I said, so we'll leave it alone. See how I'm working downwards here? Then the next thing I'm going to do, before I try moving anything from the left side of the equation to the right side of the equation, is I'm going to go ahead and finish simplifying. Now, I've got subtraction, I've got addition, and I've got a multiplication problem. Well, I can't multiply 7 times x because I don't know what x is. And I can't add 7x with 21, so even if that was next in order of operations, we wouldn't do it. Remember when you have subtraction and addition, you go from left to right? Well, I need to do 12 minus 21 here. That's going to be negative 9. Then I copy the plus 7x equals 26. At this point, I've taken care of the S of the SI process. I've simplified the expressions on either side of the equal sign as far as they possibly can go. Because I don't have like terms here, I can't add the negative 7 with the 7x. Negative 9 with the 7x, that's what I mean to say here. All right, now we're getting then into the part where we're going to isolate the variable. Now, there's some properties that I'm not writing down because you've seen them a whole lot at this point that we're about to employ. And those would be called the addition property of equality, subtraction property of equality, multiplication and division properties of equality. Those are the properties that you use to isolate the variable once both sides of the equation have been simplified. Okay, you can look those up in your textbook. I recommend you write them down just to refresh your memory. But here's the basic idea. We want to cancel out everything that's on the same side of the equation with the variable, remember? And the first thing you want to do is make sure you get the terms with the term with the variable by itself. So we want to start with canceling out the constant terms. And when you're trying to cancel out a constant term, you're trying to make it so that constant term is equal to 0. Well, you might remember the inverse property of addition. If you add a number with its opposite, it gives you 0. What we're going to do is we're going to add 9 to both sides of the equation. Now, many of you have been taught to do this. You've been taught that if you want to add 9 to both sides of the equation, that you go ahead and write a plus 9 right there, and then you write a plus 9 on the other side of the equation, and then add them together. I don't want you to do that because it's going to lead to more mistakes, I think, than it's going to help, and you're a little bit more of a mature mathematician now, hopefully, than you were back then. We are going to add 9 to both sides because of the equal sign, because that's going to cancel out the negative 9, but we're just going to write down the result of doing that. We're not going to actually write down plus 9 plus 9. Okay, so if we add 9 to the expressions on both sides, well, we would add it with the negative 9 there, and it would cancel out, and we would just have the 7x. And then copy down the equal sign. You notice how my equal signs are all aligned here. That's good practice. And then if I increase the left side of the equation by 9, according to the addition property of equality, I've got to increase the right side of the equation by 9 as well. 26 plus 9 is 35. See how that worked? All right, now I want to isolate the x from the coefficient. I want this to be a 1x right there. I don't want it to be a 7x. Well, remember, you can use the inverse property of multiplication to make a number into a 1, meaning we could multiply 7 by 1/7, or we could just divide both sides by 7, which is what we're going to do here, and I think you realize that. Again, let's not bother doing the divide by 7. We're not showing what we're doing to both sides of the equation. We're assuming anybody following your work is smart enough to just look at the expressions you have written down and figured out that you divided both sides by 7. 7x divided by 7 is just 1x, or x. 35 divided by 7 is 5. There's your solution. Now, I won't take the time to do this for every expression or for every equation, but your book is going to tell you to check your answer. And remember, the way you check your answer or your solution to an equation is you take that value of the variable that you got and you substitute it into the original equation and see if it makes both sides equal. So let's do that with this. Copy down that original equation, and where I had an x, I'm going to put my parentheses and I'll substitute the 5 there. Okay, so there's my 12 minus 7 times 3 minus x equals 26. And we just want to make sure the expression on the left equals the expression on the right. Now that we do have numbers here within the grouping symbol, we can actually do the subtraction. So let's do that first. 3 minus 5 is negative 2. And then we have multiplication to take care of before we do any subtraction or anything. Negative 7 times negative 2 is positive 14, so that will become 12 plus 14. And indeed, 12 plus 14 is 26. We know we got the right answer. Great. Let's try the next one. And if you already know what to do, go ahead and try it on your own. Then you can check to see that you got your work correct. All right? But otherwise, just watch me. And I do have to show you kind of a trick here. It's not really a trick. But I want to show you how you get rid of a coefficient whenever that coefficient is a variable. All right. So you've copied down the equation. Remember, we're going to work downwards here. Now, we've actually already simplified both sides of the equation here because you can't add 2/5 x with 12. They're not like terms. And 7, well, you can't simplify that any further, can you? So the s here is kind of already done for us in this problem. What we need to do is isolate the variable. So we're at the I part of the process. And remember, when you're isolating, the first thing you want to do is make sure the variable term is by itself. So we got to cancel out that constant term. In other words, make it equal to 0. And in this case, we can make that happen if we'll subtract 12 from it. And so what we're going to do is subtract 12 from the left side of the equal sign and from the right side of the equal sign. And that will cancel out that 12 naturally and leave us with just 2/5 x. And then we're going to have to subtract 12 from 7 as well. And 7 minus 12 gives us -5. Okay. Now again, we're going to revisit the inverse property here. If we're going to make this 2/5 x into a 1x, well, you can always get 1 if you'll multiply a number by its reciprocal. And the reciprocal of 2/5 is 5/2. Now in this case, I'm going to show a little more work than I would normally show because I want you to see how this works. We're going to multiply the left side of the equation by 5/2. And golden rule of algebra, what you do to one side of the equation, do to the other. We're going to multiply the right side of the equation by 5/2 as well. All right, and the result, 5/2 times 2/5 is 10 over 10, which is 1. So that's going to give us 1x. And then make sure you don't subtract here. That's why I put the -5 in parentheses. This is a multiplication problem. It's not 5/2 minus 5. All right, 5/2 times -5 is the same thing as 5/2 times -5 over 1. So you do 5 times -5, it's -25, over 2 times 1, which is 2. We get x equals -25/2. Now you can check that answer just the same way that we did on the previous example. I'm here to show you right now how to solve the equations. We can work on class a little bit more with the checking if you need more help with that. All right, good. So those were examples of equations where you had the variable on one side of the equal sign. Now let's look at equations where you have variables on both sides. All right, you can see that I have m's on either side of the equal sign here in this example. Now, same process. We're going to simplify both sides of the equation. To begin, and let's go ahead and start that then. You've copied the equation down. Looking at the expression on the left side of the equal sign, there's no distribution to do, which is okay. I mean, kind of nice, I suppose, but we do have a pair of like terms, and so all we're going to do is combine those like terms. We're not adding anything to both sides. We're just simply doing 9m minus 3m, and 9m minus 3m is 6m, and then we've still got the minus 11 there on the left side of the equal sign. Okay. On the right side of the equal sign, we've got a pair of like terms as well, the two constant terms, -5 and 20. Now, all we're going to do is go ahead and combine those. -5 plus 20 is 15. And then we've still got the minus 2m. All right, now, you can't simplify 6m minus 11 any further. Cannot simplify 15 minus 2m any further. So, well, we're done with the simplification process. And so now we're on to isolating the variable. Now, in this case, since we have variables on both sides, one of the things that we have to accomplish is we have to collect all the variable terms on the same side of the equation. The way we'll do that is this. We'll either cancel out the m's from the left side of the equation, or we'll cancel out the m's from the right side of the equation. I think most of you would agree with me that if we cancel out the m's on the right side of the equation, that we'll have a positive coefficient over here, and so that's what we're going to do. Now, when I say I want to cancel out this -2m, I mean I want it to become 0. I want to cancel out the entire term. I need to do that through addition or subtraction. And so I'm going to add positive 2m to both sides of the equation. Let's look at the result of doing that. On the left side of the equation, when you add 2m, well, you want to add it with its like term, the 6m. And 6m plus 2m is going to give you 8m. And we haven't changed the constant term there at all. On the right side of the equation, we're going to add the positive 2m with the negative 2m. That's what we were trying to cancel, right? So that gives us 0, and then we're still left with the 15. Okay, now this becomes like the other equations where we've got all the variables on one side of the equation. Let's cancel out the constants on that side of the equation now. We'll do that by adding 11 to both sides. That'll leave you with 8m on the left, and then 15 plus 11 is 26. And then we'll simply divide both sides by 8 in order to make that 1m. So we get m equals 26 over 8. Now, you're allowed to leave solutions as fractions all the time unless otherwise specified. You know, this doesn't say round to the nearest tenth, it just says solve. And I like exact values, so I like you leaving your answer as a fraction here. Although, I would want you to leave it in simplest terms, and so we want to go ahead and divide the numerator and denominator here both by 2, their greatest common factor. 13 over 4 would be the solution. Okay, one more example here for you. Again, if you need to go back and rewatch some of these to make sure that you've understood, I would recommend doing that. And if you think you already know how to do this example, try it out, pause the video, and then push play and see that you did it correctly. Watch my work, see if you did it right. Okay? And if you're not ready for that yet, just go ahead and watch me. So we're going to simplify the expressions on both sides of the equal sign again. And there's a lot of simplifying to do here on the left side of the equal sign. We can't do it all at once, but let's do what we can. You're going to notice 2 grouping symbols, but they have unlike terms within them, so we can't really do anything with those. But we do have multiplication. We can multiply 8 times t plus 3 using the distributive property. That's where I'll begin. So we'll have 8t plus 24 minus t minus 6. Now on the right side of the equation, we've only got a subtraction problem, and it's one we can't do because there's not like terms. So that side of the equation is already simplified. Nothing else to do there for the moment. Okay, now I made this problem up on purpose to illustrate a particular area where a lot of people make mistakes. You see that we can't add the 18 and the 24 together, and then we're subtracting this sum right here. Well, this is actually a multiplication problem right here, this negative sign in front of that subtraction problem. What we're really doing is we're multiplying negative 1. I'm going to write that in there. You don't have to write the 1 yourself. But we're really multiplying negative 1 times t minus 6. You've got to distribute that negative sign in order to make these parentheses go away. All right, so we're not doing anything with the 8t or the 24 right now. But we're multiplying negative 1 times t. That'll give us negative 1t. And we're multiplying negative 1 times negative 6. That'll give us positive 6. All right, equals negative t minus 12. Okay, now we're not done simplifying the left side of the equation. We've got some like terms to combine. You see you got the 8t and the negative t that we can combine. 8t minus t is going to give you 7t. And then we got the 2 constant terms that we can combine. 24 plus 6 is 30. Now we're done simplifying both sides of the equation, and we can go on to isolating the variable. All right, we want both of our variables on the same side of the equation if we can make it happen. Let's cancel out the negative t on this side of the equation by adding positive t to both sides of the equation. All right, 7t plus t is 8t. Leave the constant term alone for now. Negative t plus t is 0, and we're left with negative 12 then. Now we can cancel out the constant terms on the same side of the equation as the variable by subtracting 30 from both sides. Leaves us with 8t equals, and negative 12 minus 30 is negative 42. And then we'll go ahead and divide both sides by 8 and get negative 42 over 8, which in simplest terms then is going to give us negative 21 over 4. Now, if you wrote that as negative 5 1/4, a mixed number in other words, that's fine. If you wrote it as negative 5.25, that's fine. As long as you're not rounding, I don't care how you leave the answer, truly. Okay, as long as it's simplified, of course. There you go. That's how you solve linear equations. Hope that process seems simple enough. You're going to have plenty of exercises to try. I recommend trying some on your own before you come to class tomorrow. All right, thanks for your attention. I'll see you later.